Hello, my name is Yoni Maltsman. I'm a math major at Harvey Mudd. I'm currently taking a gap year, but when I return back in the fall, hopefully, I will be a junior. And over the past summer, with the help of stipend from the Office of Community Engagement, I was able to intern with Lucy Parsons Labs, which is a nonprofit organization in Chicago that does a lot of work around transparency and accountability with regard to surveillance technologies and how the Chicago police use surveillance. So I'm going to talk about that a little bit today. So just to start off talking about LPL, I'll just quote their website, their mission statement, which is Lucy Parsons Labs is a charitable Chicago-based collaboration between data scientists, transparency activists, artists, and technologists that sheds light on the intersection of digital rights and on-the-street issues. So basically, LPL does a lot of work investigating how the Chicago police and other municipal organizations use surveillance, and also how a little bit about how private entities and other entities use surveillance technologies. And so a big way they do that is through something called the Freedom of Information Act, the abbreviation's FOIA, which basically enables everyday people to request records. They could be emails or financial documents or pretty much any kind of records from public agencies like the police or like an education department or like a mayor's office. And so through this, LPL has been able to do a lot of groundbreaking investigative work. They've revealed how CPD uses and spends money on various surveillance technologies such as facial recognition and social media monitoring. They also do a lot of important technical work, such as they provide digital security trainings for activists and for at-risk communities on how to like keep digital security and then keep cybersecurity in these activists kind of work, which can be vulnerable to various risks. And they also developed a tool called Open Oversight, which is an open source platform that enables people to report police misconduct. And so when I was at LPL, over the summer, I primarily was working on their surveillance primer, which is like this website where they talk about various surveillance technologies, and I'll talk about that more in a bit. And it was recently relaunched as chicagopolicesurveillance.org, so check that out, it's pretty cool. And I was also helping a little bit with organizing meetings for the Press Pause Chicago Coalition, which was seeking to ban facial recognition in Illinois. That's kind of on pause now with other organizing stuff going on, but something that has been continuing to go, which was sort of formed over the summer and was being formed throughout the fall, is this anti-surveillance network in Chicago, which is like a coalition of various organizations in Chicago, which is working to dismantle and advocate around surveillance and preventing abuses from surveillance. So the surveillance primer that I was working on is basically this website that talks about different surveillance technologies used by the Chicago police. So you can see there's quite a long list of different technologies that they use. And so I'll give a quick example by going on their website, on the chicagopolicesurveillance.com website, this primer. So this is an example with license plate readers, which is one of the surveillance technologies that the police use. So it talks about where they're used, the locations, the costs, the capabilities, the efficacy, and the legal and privacy concerns around this technology. And this is the case with all the different technologies that we have on the site. And so a lot of this, a lot of the content that's written here is stuff that I wrote during my internship. I did not do the cool design and graphics stuff that was like a professional designer, but I wish I could have. But I did do some of the writing and content, which was pretty cool, doing like sort of research on documents that LPL had acquired through public records requests, basically to educate the public. And in terms of how this experience impacted me and sort of what I'm going forward with it, going forward from it with, I think it deepened my understanding of the role of technology in society. I think one of the reasons that I came to this internship was because of the conversations that I was having at MUD and at the 5Cs around the impact of like the role of technology in society, and surveillance technology is like a really contentious issue that we talk about in that conversation. So it really helped. So having this experience really helped flesh out sort of how I understand it, and help me sort of develop questions to analyze that and dig deep into that. And it's also helped me develop connections and experiences with individuals and organizations that are working around surveillance and working to advocate against surveillance and against like extensive policing and police use of surveillance, and how that is threatening civil liberties. So that was so it was a really cool experience, and I'm really happy I did it. And lastly, I'd like to thank those who helped make this experience happen, the Office of Community Engagement and the sponsors of the internship for providing the funding and the coordination, and also to Freddie Martinez, who's the director of LPL and who I was working really closely with over the summer, is basically supervising me, and the entire LPL team for welcoming me in and making it a really great experience. So thanks for listening, and I hope you enjoyed.
Hello, my name is Aubrey Egerter, and I'm going to be talking about my internship with KAV Helmets during the summer of 2020. So first, for some background on KAV and its purpose. With over 3.8 million concussions happening per year, concussions are clearly a huge issue within the sports world. Human contact is embedded in many sports and is nearly impossible to separate it without changing the very nature of the sport. As such, KAV hopes to preserve the nature of the sports we love while simultaneously helping protect athletes from serious head injuries. As an athlete myself, KAV's mission and focus on safety really spoke to me. And as an engineer, their unique approach to helmet design really intrigued me. And I'll be talking more about that on the next slide. So quickly, in a nutshell, KAV Helmets seeks to decrease the number of concussions that ice hockey players experience on the field. They're doing this through designing unique, customizable 3D printed helmets that increase player safety and comfort. So a little bit about the internship itself. My work over the summer focused on modeling and optimizing the internal energy management system of KAV's helmets. Alongside recent MUD-grad and current Caltech PhD student Kevin Nakahara, I developed an understanding in metamaterials and cellular structure behavior to test, evaluate, and improve on the current helmet design. The ultimate goal was to become one of the very few helmet companies to design a helmet that has a 4 or 5-star Virginia Tech rating. As for lessons learned, this internship was an incredibly holistic experience. So not only did I learn a lot about material properties and cellular structure behavior and other really fascinating technical concepts, I also got a taste of the business side of things from Whitman, the CEO, and also a MUD alum. It turns out that ice hockey players can be very particular about their style, which brought up an interesting question of how to design both for safety and in a way that satisfies players' taste. Because of course we want them to actually wear these helmets. I also learned a lot about troubleshooting and working around roadblocks. There were of course several snags in our process that required a shift in perspective so that we could still achieve our goals. While frustrating at times, these actually turned into perfect moments for me to get creative in testing methods and new approaches. For example, while we initially sought to use FEA as an analysis and modeling method, we gradually switched to using more rapid prototyping and physical testing to analyze our designs. This move away from FEA was due partially to the complexity of the helmet structures, limited material modeling capabilities on the software, and also a very, very slow runtime. Needless to say, design iteration and rapid prototyping soon became my best friends. Working with the KAV team, Whitman, Dave, Paula, and Mike also showed me the importance of leadership, workplace accountability, teamwork, and peer support. The tight-knit and collaborative environment they have created has made me consider new ways to be a leader and promote community, especially in a remote setting. Last but not least, I saw the power of having personal passion in your work and how important it is for carrying a project forward, especially on those days when it can be hard to find motivation. Working in a startup is hard work and requires a lot of commitment. So seeing the investment and dedication of my peers to the company mission every day was inspirational and eye-opening as I start to think more about what impact I want to make as a MUD grad. KAV's work is significant because helmet technology is so limited, particularly in certain sports, including ice hockey. KAV is producing a novel approach to helmet design that is backed by lots of scientific research and testing with results that exceed those of other more classic helmet manufacturers. Kevin and my work on energy absorption created a foundation of real test data that can be used for material and structural decisions in order to better maintain player safety and prevent concussions. And while I can't say any specifics, I recently checked in with the KAV team and heard that they are building off that knowledge to continue iterating their future designs. And now I'd like to conclude this presentation by giving a huge thank you to the KAV team, Whitman, Dave, Mike, and Paula, for their willingness to share their passion and knowledge and for welcoming me as part of the KAV team. I also want to thank recent Mud alum Kevin Nakahara, who is my partner in this internship. And lastly, I want to thank Danny and Gabriella in the Office of Community Engagement for all their support throughout this experience. Thank you.
Hi, everyone. So I'm Tom. I'm a junior MCB major at Harvey Mudd College, and I am the recipient of the New Millennium Learning Fund. Today, I'm going to present the projects that I did over summer for the Learning Fund at the HMC BioMakerspace. So first off, I would like to introduce who we are. We are a nonprofit student-initiated lab that supports open source biology projects and events at the Claremont colleges. And in the summer of 2020, I mainly worked on two projects. One was the DNA printing project, which serves to enable the printing of a user-chosen image on electrophoresis gels using DNA as the inks. And the second one is the BioFoundry project, which serves to create an automated cloning pipeline for biologists using the fast cloning technique. There are also more things or projects that I did in the BioMakerspace in collaboration with other members of the space, which you continue to do during the last semester and also this semester. But I will focus on the two main summer projects for this presentation. So the first one is DNA printing, which aims to print an image on the gel with DNA as the ink, as I mentioned. So this is obviously an interdisciplinary project. We firstly need to calculate the math formula that turn image pixels into the DNA's running distance on the gel. And based on that formula, we need a platform where users can put in images they like and to generate a PCR protocol for printing the image on the gel. And then the PCR protocol needs to be actually performed by users to print the image on the gel in reality. As one of the main computational biologists in the lab, I was responsible for creating a platform, as I mentioned, that is good for image submission, and it's able to automate the image processing process and also generates a PCR protocol. It also allows menu adjustments, which we will see in a few minutes. So the first window you will see in the software is this. So intuitively, the first thing that you will do with this window is to select an image to be printed on the gel. So then the next window that will pop out will ask you to select images to be printed. After you select it, it will have a window for you to confirm the image. After you confirm the image, the software will automatically analyze the chosen image and generate a preview window as shown in the left-hand side. If you're unsatisfied with this preview, you can choose to manually adjust our protocol so that certain pixels on the gel can be printed or not printed as you like. So after that, you will successfully generate a PCR protocol for printing this image on a gel. In addition to that, so one particular adjustment that we make this platform able to do is that you can adjust the number of lanes on a gel box or the number of colons in the image shown here, for example. This can change according to the lab equipment that a user has. So the way to do that is that, remember, at the beginning, you have a settings button in the entry window. When you click on that, you can change the number of lanes as you wish. So that is the DNA printing project, which can be found in this GitHub link over here if you would like to use it. The second project is the BioFoundry project, which aims to build a plasmid building factory for the 5Cs to enable this research in general at the 5Cs. So as I, similar to before, for this project, there are also many wet lab components to it that I did not participate in because I simply do not have the lab equipment to do it during COVID. On the other hand, Roya, another main member of the BioMakerspace, did most of the wet lab components. So for me, I mainly worked on a computational part, which is to create a command line tool that is an automatic primer designer for digesting plasmid DNA, and is also able to automatically design primers for fast cloning experiments. Note that the outputs for this kind of, for my command line tool is openable in Benchling, which is a really popular biology lab notebook online. And the fact that I made the outputs openable in Benchling enables it to connect with the general working environment of a bench biologist seamlessly. And the link to this project can also be found in this GitHub link over here. In addition to the two main projects that I did, I also was involved in several other projects and events of the BioMakerspace. For example, we started planning out the HMC BioMakerspace talk series over summer, which was pretty successful during the fall semester when we actually held it. We invited 4 professors to give their talks and had a bit less than 200 people to attend our talk series, which is pretty good. And the second thing that we did was to create from scratch a bio-collaborator website, which serves to present and enable collaboration for different biology projects, which is shown in this image over here. The link for this website is just biocollaboratory.com if you would like to visit it. And that is all that we would like to present today. Thank you so much for listening. And if you are interested in BioMakerspace, please feel free to contact me or Roya. And hope you have a really nice day.
Hi there. We are the LAUSD clinic team. We're contracted by the LA Unified School District. We are liaisons at LA Unified School District are Esther Solomon, Seema Puri, and Laura Hayes. And I'm the project manager of the team. My name is Sean Pine.
I'm Trevor Nogues.
And I'm Justin Grant.
And I'm Bhavana Bheem, and although not here right now, we have another team member, Fiona Plunkett, and our advisor is Professor Young.
And we're super glad that we were invited to present our project, and we're happy to share it with you all.
Thank you for that introduction, Sean. So our team is working with the Los Angeles Unified School District, which is the second largest school district in the United States, serving over 600,000 students. In the past century, racially restrictive housing policies in Los Angeles led to the geographic segregation of racial and ethnic groups across the country. These geographical divisions, paired with school-enacted policies in the 1950s, kept students of color out of more socioeconomically well-off schools. These policies have resulted in a segregated school system that persists to this day. For years, students have affirmed that this inequity is still present in the school system to this day. This contributes to a measurable achievement gap between students of different racial and socioeconomic backgrounds. One program that helps bridge this achievement gap is a program called CTE, or Career Technical Education, which aims to help students prepare for college and careers. These are programs where students take sequence courses that give students opportunities for hands-on learning that connects them to a specific field of industry, like engineering or digital media. Students will take multiple courses in a single pathway, or a pathway is a specific topic. These programs give students practical skills in their field, as well as a chance to meet industry professionals and learn about career options in that field. These programs also have a measurable improvement on student outcomes, especially for historically disadvantaged student populations in the school system. For instance, English language learners are more likely to graduate high school if they are in a CTE program. Sean will now take you through the application process.
Thank you, Justin. To receive funding, pathways apply for funding from the district. The district distributes about $13 million every year based on applications that teachers submit. The current application is several pages long, and every question requires evidence and documentation to support funding requests. For example, a teacher will have to document when they meet with industry partners and show records of this interaction. Compiling all this evidence can be very time intensive for teachers. With this knowledge in mind, we surveyed over 150 CTE teachers and found that 43.5% of teachers thought the workload was unreasonable. This demonstrates that the application can be far too time consuming for teachers to complete outside of their normal responsibilities. For example, a pathway might have, a school might have a great pathway, but the application process can be a burden for the teachers in that pathway and doesn't help them highlight how great their pathway is. In theory, the application should identify and fund pathways that meet standards that are determined by the California Department of Education. And these criteria were recently updated to emphasize equity as a key goal of CTE programs. The current application process does not consider if pathways are increasing equity, in other words, moving toward a more equitable outcome for their students. And it's not really easy to make that determination with the current process that LAUSD employs. Our liaisons at LAUSD also believe that due to the high length of time it takes to complete the application, schools that are less resourced may have schools that are better resourced may have an easier time writing good applications. While conversely, schools with less resources, where teachers have denser workloads and have less outside assistance on applications, may have a more difficult time producing high quality applications. Unfortunately, this means that less resourced teachers may have pathways that meet all of those standards laid out by the state, but are so busy that they're unable to complete high quality applications and receive the funding that they deserve.
Thank you, Justin and Sean, for introducing the problem. So following this, our clinic project's main objective is to create a new decision-making process for CTE pathway funding that is measurably equitable and justifiable. This objective will require us to revise the current CTE application form, as well as incorporating a data-driven algorithm for the funding process. So as Sean mentioned in the problem introduction, there's a lot to include on the application that can be burdensome for both teachers and those who grade the application. So one of our team's objectives is to streamline the application while not sacrificing the quality of the application just to make the process faster. We are using an iterative process between conducting surveys and revising the application. We have already gathered input and feedback from teachers, modified the application, and asked for more feedback on our proposed revisions. Our final revised application has almost been completed and will be paired with the data-driven process.
Thank you, Trevor, for the explanation on the application. For the data-driven algorithm, our goal is to encourage schools to have their pathways be accessible to all of their students, be representative of the school's student body makeup, and meet LAUSD equity standards. Thus, we are leveraging existing data sets about LAUSD schools and CTE pathways to create different models that take into account the demographics and statistics of the pathway when making the funding decisions. We are then going to compare and contrast our models on their ability to have equitable distributions of funds across pathways. In the end, we wish to justify a new data-driven model for funding decisions that will be paired with the application form. We want to make sure our models, or the model we present, is justifiable and transparent to all CTE stakeholders. Currently in this process, we are at the point of running our models on previous year's CTE pathway data sets. And the next step is we're going to measure the equity of the model decisions about funding. So we're coming along on that deliverable as well. And so as for our big picture, our goal is to help ensure a more equitable distribution of CTE funding to LAUSD schools. And to do this, we have two steps. One is to improve the funding application process, and two is to develop an automated assessment of CTE pathways aptitudes based on state equity standards. We're having a great time working with LAUSD, and we are honored to present our work at the Voices of Engagement. Thank you for listening, and have a great day.